Hello everyone, welcome to another new video from my channel. This is Shayon and today our topic is one of the most important name reactions for CSIRNET, GATE and IIT JEM, that is Baeyer Villiger oxidation. So just to start, this is a very simple reaction and this is a name reaction, but the mechanism you have to understand by some orbital point of view. So Baeyer and Villiger actually found that treating a ketone with a peroxy acid can produce an ester. So an oxygen atom is going to be inserted just next to the carbonyl group. This oxygen atom is going to be inserted in nu just next to the carbonyl group in presence of CaCl3 solvent. So this peroxy acid can produce a new oxygen atom and that is going to be inserted just next to the carbonyl group. So this reaction is known as Baeyer Villiger oxidation, and this is accompanied by either the use of a solution of per acid in acetic acid or in aqueous solutions which have some weak acidity. So any per acid, any reagents which have this oxygen-oxygen per bond like MCPBA, metachloroperbenzoic acid, and let's say you have a perbenzoic acid. So that's all this type of compound, or let's say CF3CO3H. So this oxygen-oxygen per bond is important for the reagent. So if you have this type of reagent in presence of ketone, it will create an ester. So to write the product is very easy. Insert an oxygen atom just after the carbonyl group. As you can see here in example, you have a RCOR. This is the carbonyl group. So you have inserted an oxygen atom here just after the carbonyl group. The same for the second example also. And third example also, you have two benzyl groups. So the new ester, that's the product, one oxygen atom has been inserted to just after the carbonyl group. Now variety of studies for Baeyer Villiger actually indicates the mechanism is very simple, that goes through basic two-step intermediate. That is, here you have a carbonyl group which this carbon atom is actually positive and this oxygen atom is actually negative. There are some delta positive charge here and you have a H plus. So this oxygen lone pair will first take this H plus atom and this lone pair of this oxygen atom will attack here and leave this oxygen as O minus, and this form this type of tetrahedral intermediate, and this is very common for carbonyl attack by some nucleophile in acidic media. So this will form this type of tetrahedral intermediate, and next step is actually the most important step. This step is actually the most important step for the reactions, which is the slow step and also rate determining step, which is the concerted oxygen-oxygen heterolysis as well as migration. Actually in product we can see that oxygen bond is going to be broken and some R group has been migrated, that is from this type of product. So this migration has been happened like that. This oxygen lone pair has came here and make a double bond which is gone here, the double bond OH, and this R group has been migrated to one oxygen atom and this oxygen-oxygen bond has been heterolyzed, leaving R COO minus. So to look at the orbital overlap interactions, you have this tetrahedral intermediate here. One is attached with R, another is OH, another is CR, what is going to be migrated. Now this OO bond is breaking. So what can be the orbital mechanism? That HOMO of this CR bond is actually going to be donate one pair of electrons to the LUMO of this oxygen-oxygen bond. So bond order of this OO is actually decreasing. That's why this OO bond is breaking. by attacking this R group here. So this R group in next making an orbital overlap with this oxygen, and this R has been attached with O, and this OO has been bond has been broken, and this produce this type of compound RCOOH and OR. So this oxygen is actually positively charged because 3 bond has been produced for this oxygen. So this on deprotonation gives this type of compound. So now this is the slow rate determining step. This step is very important. So behavior of this migrating group, which will be going to be migrate, that directs the kinetics and yield of the reactions. That will be the main important topic to discuss, and that we will discuss in the next video. Thank you for watching.